Welcome to this explainer, where we're looking at scaling laws beyond compute and diving deep into the energetic structure of intelligence. Today, we are going to jump right past the surface level hype and uncover the fundamental architectures that are truly driving artificial intelligence forward. If you've been keeping an eye on the industry, you already know we're in the middle of this massive, explosive growth. But what's actually happening under the hood, and more importantly, what comes next?
So, let's start with a really basic question. Is making an AI bigger the exact same thing as making it smarter? Man, it's incredibly tempting to just say yes, isn't it? I mean, we've all seen the headlines. There's this widely accepted illusion right now that if you just scale up a model size, if you just pump more data and insanely more compute into it, it's going to automatically produce true, reliable intelligence. Well, today we're going to challenge that assumption head on.
All right, let's look at the success of scaling and why bigger really did seem better for a while.
Now, we absolutely have to acknowledge the undeniable triumphs of recent AI development. The industry essentially realized that by shifting to a highly predictable industrial process, they could rely heavily on three traditional pillars of scaling: parameters, training data, and computational resources. And by steadily cranking up these inputs, researchers have reliably driven massive, unprecedented performance gains. It proved, without a doubt, that capability could emerge from sufficient scale. But, as you'll see in a moment, capability is really only half the story.
Which brings us to capability versus control, and the real limits of raw scale.
Because here's the massive complication we're facing today. Absorbing vast amounts of human data creates these impressively powerful predictive engines, sure, but it completely fails to actively organize that complexity. We really have to separate two ideas here. First, there's capability. This is simply what the system can produce under highly favorable conditions. It's the AI writing a brilliant legal analysis or solving a tough coding problem when you prompt it perfectly. But then there's control. This is the ability to repeatedly produce the right behavior under real, messy constraints. It's about maintaining goals, respecting rules, and keeping long-term coherence over time. Look, a larger model can definitely contain more patterns, but scaling computation is absolutely not identical to scaling intelligence. True intelligence requires that control side. It requires the ability to maintain and transform meaningful states under constantly changing conditions.
So, let's introduce the energetic paradigm. This is an entirely new structural truth for AI.
To bridge the gap between capability and control, we essentially have to redefine our entire concept of scaling. Instead of viewing scaling as the literal creation of intelligence, we actually need to see it merely as the injection of raw energy into a system. So, the energetic paradigm is a framework that defines AI scaling as energy amplification, and that energy must be explicitly organized across finite resources, competing objectives, and changing constraints if we want to achieve durable intelligence. The crucial point here is how we define energy. We aren't just talking about electricity. Energy means literally any limited resource. That includes computational power, memory capacity, the data itself, engineering labor, and yeah, even the financial capital funding the whole run. You can amplify that energy all you want, but unless it's explicitly organized, you simply don't get durable intelligence.
To put that into perspective, think about a simple corporate analogy. A company with 10 times more capital doesn't automatically become 10 times more competent. That makes intuitive sense to us in the business world, right? Increased resources only expand your opportunities. They absolutely do not guarantee effective resource allocation. Dumping more money into a poorly run business just creates a bigger, more expensive, poorly run business. And you know what? The exact same logic applies to artificial intelligence.
This brings us to a quote that brilliantly illustrates the ultimate limitation of traditional scaling. Scaling amplifies the strengths and weaknesses of the architecture being scaled. This is absolutely crucial to understand. If you dump more computational energy into a flawed or fundamentally unorganized architecture, you don't magically fix the flaws. You just magnify its instability. It might generate much better sounding text, sure, but its inability to follow constraints or stick to a long-term plan will just become a much, much larger problem.
Let's move on to the energy allocation problem and how we actually govern computation. We're transitioning now from the theoretical idea of energy to a highly practical engineering hurdle. If an AI system has a massive but ultimately finite amount of computational power, it has to actively distribute this budget across some core functions. We're talking memory and representation, planning and search, verification, action and correction. It's a delicate balancing act. For instance, if the system allocates too much energy to planning, it delays action and just becomes totally paralyzed. But if it rushes into action without allocating enough energy to verification, that causes a catastrophic failure.
True intelligence requires the dynamic, active management of this exact budget based on the very real risks and constraints of the current moment.
When we methodically compare these dimensions of scaling, we really start to build our understanding of where AI is heading. Traditional AI scaling takes more parameters and gives you better prediction. Simple enough. Experience-based scaling takes more interaction and gives you better adaptation. But energetic scaling requires better state management to achieve better overall intelligence. Managing complex states, knowing exactly what you're doing, why you're doing it, and what constraints you are operating under, that is the ultimate form of scaling. It's just not about throwing more parameters at the wall anymore.
So what does this look like in practice? Enter large energy models, the blueprint for reliable AI.
To actually achieve this better state management, we need a totally new kind of architecture that moves way beyond simply predicting the next word. A large energy model, or LEM, relies on 5 interacting layers. Step 1 is the capability layer. This is your raw predictive power, the massive foundation we've built so far. Sitting right on top of it, step 2 is the state layer, which tracks exactly what is happening in the environment. Step 3 is the constraint layer, ensuring all the legal, physical, and ethical rules are actually followed. Step 4 is the allocation layer, constantly distributing that energy budget we just talked about. And finally, step 5 is the control and revision layer. So the raw power at the base is constantly constrained, directed, and continuously revised by the highly intelligent layers above it.
A true large energy model does some really profound things. It maintains an active understanding of its task and environment at all times. It represents persistent legal, physical, and ethical limits, and I mean as hard constraints throughout the operation, not just as polite suggestions you throw into a prompt. It evaluates risk to determine if it actually needs to pause and verify its work. It actively reallocates resources when its current strategies are failing. And most importantly, it preserves long-term coherence across changing states. It corrects errors permanently and handles competing objectives without ever losing sight of its original purpose.
Let's bring this all together under organizing future intelligence and what this next transition looks like.
Now, I want to reassure you that the energetic paradigm doesn't reject traditional scaling at all. We are absolutely still going to need massive compute, broad representations, and vast knowledge. But look at how this permanently shifts our perspective. The old question of the AI industry was always, how much information can the system absorb? The new question is, how much complexity can the system organize while preserving stability and achieving goals? That is the true measure of advanced intelligence. We are permanently pivoting from an era of raw resource accumulation to a brand new era of intelligent, dynamic organization. Which brings us to our final and maybe most important takeaway. The next AI revolution is not about scaling the model, it is about scaling the organization of intelligence. When we realize that true intelligence isn't just about raw predictive power, but about the carefully governed application of that power, the future of artificial intelligence takes on an entirely new and much more reliable shape. So the ultimate question for all of us is this: how well will we organize the immense energy we are about to unleash? Thanks so much for joining me for this explainer.